This question is one that requires us to be very detailed in our drawing that we make to understand what's occurring. So we have this ground, and we have a projectile fired from a launch point. So we'll call this the launch point. And it's fired as a projectile, and it would take this parabolic path, like so. Two halves, while it's flying, the two halves is split that hit the ground at the same time. So no matter where this is, we could pick any particular point. Let's say it explodes when it's right here. And it splits in half. Now, if this one had gone that way and that way, they definitely would not hit the ground at the same time, because this would end up taking this path, and this has a V0 downward. They're definitely not going to hit the ground at the same time. For them to hit the ground at the same time, they must be at the same height. And the only way that can occur is if it explodes and the pieces go this way. No, any other orientation besides parallel to the ground will yield different landing times. Every object, if they're going to land at the same time, they must be launched horizontally, like horizontally off a cliff or a table or something like that. So we know that about the explosion. It must take the blue trajectory. If it had not exploded, it would have landed at point X. So this is point X, and we are told that that's a distance r to the right of the launch point. After the explosion, one of the halves lands at point Y, which is a distance 2r to the right of the launch point. So here's 2r. So one goes this way. If air resistance is negligible, where did the other half land? Well, we know that this is an explosion. We're actually told it's an explosion. So P0 equals P. And we have 0 beforehand, and afterward we have P left and P right. So P left must be equal and opposite to P right. P left and P right. You need P's. P left must be equal and opposite to P right. And to two halves of equal mass. So this is MVL equal and opposite to MVR. Well, the M's are equal. So the velocity of the left must be equal and opposite to the velocity of the right. So here is our speed V. This is speed V. And if they're both traveling at the same speed V in either direction and they land at the same time, they're traveling for the same length of time, then that means the distance they travel must be the same. And so if the one were shot ahead, a distance r, the other would be shot back a distance r, and being shot back a distant r means it would have landed at the launch point. Choice B. Another way to think about this is that whenever we have a system where it looks like there are two masses or something splits and so forth, well, we consider this object as having a center of mass. And as it explodes and the pieces move outward, the center of mass maintains its velocity. Newton's first law, an object wants to preserve its current motion, and so we could replace that with the center of mass of the object. Seeks to keep its current velocity. So the center of mass, keeping its current velocity and path, the center of mass has to be right here at r. So if at the end on impact, if one of them is at 2r, the other one has to be at the other r. The center of mass is here. It must be in the middle at point Y at all times, at point X, excuse me. Center of mass must be there at all times. So if one mass is an r to the right, the other one must be an r to the left. But we can also show this by using the momentum explosion and kinematics.